Hello everyone, my name is Thorvar. I am an undergraduate at the University of British Columbia, Okanagan. Today I'm going to present to you a paper titled FaceUI, Leveraging Front-Facing Camera Input to Access Mid-Air Spatial Interfaces on Smartphones. This work is done in collaboration with Mariam, Dr. Armstrong, and Dr. Hassan. Now, when using a smartphone, people typically hold the phone in front of their face to easily access on-screen content. So this enables the front-facing camera on the device to track the spatial location of the phone relative to the user's face. We can further use this spatial information to place virtual interfaces into the mid-air space, where users can move the phone in the space to access the interfaces. Based on this idea, we present FaceUI. It's a novel strategy to access mid-air face sensor spatial interfaces with off-the-shelf smartphones. FaceUI uses the smartphone front camera to track the phone's mid-air position relative to the user's face. This self-contained tracking mechanism leverages the empty mid-air space in front of the user to accommodate virtual windows, in which the user can browse through different items by moving the phone in the space in front of their face. So we inform our implementations of FaceUI by first studying essential design factors. We conducted 3 studies as follows. In the first study, we explore suitable phone-to-face distance and direction for accessing virtual UIs in the in-air space. In the second study, we identify suitable viewing angles for browsing and inspecting content that reside in the in-air space. Based on the results of the first 2 studies, we'll design FaceUI and compare its performance with the traditional touch input for an analytic task where users are required to browse a set of calendar events before reaching a decision. Now, I'm going to briefly talk about a few prior work that are related to our work. So, prior research have explored ways to extend smartphone input capacity by shifting the interactions space into empty inner space surrounding the user body and their mobile devices. So for instance, virtual shells investigate accessing virtual items that are located inside half a sphere in front of their body. Similarly, AD Bind investigated leveraging the mid-air space around the smartphone for accessing on-screen content. Zha and colleagues use a combination of facial movement, device motion, and touch for designing a face-centered interaction technique on smartphones. To our best knowledge, ways to leverage face-centered in-air spaces to access virtual user interfaces with off-the-shelf smartphones have never been explored before. So we started with developing a self-contained smartphone applications to track position and orientation of the smartphone relative to the user's face with front-facing camera. We use face detection API from the Google ML Kit. Among available face tracking related measures, our software relies on yaw, pitch, and distance data. We use this information to spatially track the phone in front of the user's face. Now, we started our explorations by investigating the comfortable phone-to-face distance while accessing the UI in both horizontal directions and vertical directions relative to the user's face. We observe that the participants are faster accessing item in horizontal direction over vertical directions. From subjective feedback, we found the participant prefer holding the phone in close distance than far distant. With another user study, we explore suitable viewing angles in both vertical and horizontal directions, where users are comfortably view and access on-screen items on smartphones. As you see here, we place the targets in different horizontal and vertical angles, where users are required to move the phone to the target angles and perform counting tasks. With the target angles for each direction, we see that the participant's performance degrades significantly at the highest angle in each direction. We also observe that accessing the screen content visually is slower when the phone is positioned in the up direction than in any other direction of inner space. Now, using the findings from two previous studies, we evaluate practical usage scenario using FaceUI, where users are required to browse multiple windows for retrieving information. Consequently, we'll design a calendar app to compare the performance of FaceUI with the traditional touch interfaces. Now, with the traditional touch interface, the task involves selecting date and inspecting several events on that date. This inspection requires user to switch back and forth between lists of events and the detailed view. With FaceUI, we leverage the empty mid-air space in front of the user to accommodate detailed view. The user can access the details on the events on the detailed view by simply moving their phone in mid-air rather than touching the screen. Our study results show that participants are significantly faster with browsing information using the FaceUI than the traditional touch input. We believe this is primarily due to the fact that FaceUI enables quick retrieval of virtual UIs by moving the phone, whereas touch interfaces requires user to switch in between windows, tap, swipe, which is known to be costly. Now, to demonstrate how face-centered spatial interfaces can be used in off-the-shelf smartphone, we show two applications here. First, FaceUI image browser loads the images onto the inner space in front of the user into a grid. User can browse them by moving the device along horizontal and vertical directions. Second, we integrated FaceUI into a chat interface for user to scroll through the messages by moving the phone vertically. Now, we summarize and present our key findings at design guidelines for designer to build interfaces similar to FaceUI. We recommend designer to place UIs in the mid-air space within 40 centimeters from user's face. In addition, participants reported difficulties accessing items in the up region. Thus, limited or no items should be placed in this region. Results from our study suggest placing items between 40° left and 40° right in the horizontal direction, between 20° up and 30° down in the vertical direction. We also suggest that designer consider using mid-air space to place UIs to perform any browsing intensive task with FaceUI enabled user interfaces. Now that we show FaceUI is a promising solution to leverage mid-air empty space in front of the user for browsing on device content with off-the-shelf smartphones. Thank you for listening. I'm open to answer any question that you might have.